Hello, pre-calculus. I'm going to make you a little video on how to graph some logarithmic functions. These directions are a little bit different. It says identify domain and range. I can do that part too, but I don't think your homework says to do that. So first, I am going to look at the parent function, which is y equals log base 6 of x. And then I'm going to rewrite that in exponential form. The answer to a log is the exponent. So 6 to the y equals x is what I'm going to be making my table based off of. Because the exponent is the y value, that's where I'm going to put my -2, -1, 0, 1, and 2. 6 to the -2 means 1 over 36. So a negative exponent means I'm going to bring this 6 down to the denominator and square it. 6 to the -1 is 1/6. 6 to the 0 is 1. 6 to the first is 6. And then 6 squared is 36. Now, looking at my transformations. Oh, I'm going to graph that part first. So -2 in the y's is at 1/36. Very small. Go. 1/6 is down at -1. There's my x-intercept, always with the parent function, 6, 1, and 36, 2. Obviously, I'm not going to get on my graph. So there's my parent function. Now I'm going to do my transformation. So my transformation here is right 1, down 5. So I'm going to take all of my x's and I'm going to add 1 to it. So I have a 1 and a 1/36. 1 and 1/6. 2, 7, and 37. Then I'm going to take all my y's and it says I'm going down 5. So -2 down 5 is -7. -1 down 5 is -6. 0 down 5 is -5. 1 down 5 is -4, and 2 down 5 is -3. So that's what I'm going to graph now. 1 in a 16th is down here at -7. 1 in a, not a 16th, 36, sorry. It's hard to, my pen was too thick there. 1 in a 36 is down here at -7. 1 in a 6th is down here at -6. 2 is at -5. 7 is at -4. And there's my graph in blue. So this one says identify domain and range. So look at my domain. Here's my asymptote right there at 1. My asymptote is at x equals 1. So I don't go past that line. So my domain is starting there. My domain, come on. My domain is going to be from 1 to infinity. And my range for a logarithm is always all row numbers. Notice how my line goes down. And as it goes to the right, it's going to be getting higher and higher and higher. Okay, I'll do one more. I'll do this one, number 2 over here. So, again, I am starting with my parent function. So my parent function without any transformations is y equals log base 5 of x. So I'm going to rewrite that as an exponential. The answer to a log is the exponent. So that's 5 to the y equals x. Making my table. -2, -1, 0, 1, and 2. I'm plugging in for y because that's the exponent on 5. So 5 to the -2 means 5 squared, but in the denominator. 5 to the -1 means a 5 in the denominator. Anything to the 0 power is 1. 5 squared is 5, or 5 to the first is 5, 5 squared is 25. Okay, my transformation is, again, right 1 and up 3. So I'm going to add 1 to all of my x's. So I'll put my other table over here. Add 1. 1 and a 25th. 1 and a 5th. 2, 6, 26. Up 3. I'm going to add 3 to all my y's. So that's 1, 2, 3, 4, and 5. So my original parent function is at 1/25th, I'm down here at -2. 1/5, I'm at -1. There's my x-intercept, 5, 1, and 25, 2 is going to be off the page. Parent function. Asymptote at x equals 0. Okay, here's my transformation. So I'm at 1 and a 1/25th, and my y value is 1. 1 and a 5th, my y value is 2. 2, 3, 6, 4. My asymptote again is at x equals 1, making my domain 1 to infinity, and my range all row numbers. Thanks for watching.